Alright, today we're going to talk about dilations. This is our last transformation that we are going to talk about for this year. A dilation, guys, is a transformation in which a figure stretches or shrinks with respect to a fixed point called the center of dilation. And for our class, the center of dilation is always going to be the origin, so you don't have to worry about trying to figure that out. We're going to use the origin as our center of dilation. So basically what you're going to do in this one is you're kind of going to be multiplying. And you can multiply by numbers greater than 1, which will enlarge the shape, or numbers less than 1, which will shrink the shape. And the number that we multiply by is called the scale factor. And that is the ratio of a side length of the image to the corresponding side length of the original figure. So what we're doing in the scale factor is I'm telling you what you're multiplying by. This is actually quite easy to draw dilations. Probably you'll find this easier than our rotations formula from yesterday. Okay, if you're not done writing those down, go ahead and pause. I'm going to move on to the second slide. Okay, in our slide here, we're going to be dilating a figure. So let's see if we can zoom in a little bit here. We're going to be dilating our figure here. Okay, and what we are going to do is I have the triangle, and I kind of pre-drew it, so I'm just going to label it here because I don't have my labels on there. So P is negative 1, 2, Q is 3, 1, and R is 2, negative 1. So now that I have my labels on there, what I am going to do now is I'm going to dilate with a scale factor of 3, which means I'm going to take my original coordinates and multiply them all by 3. So it's pretty simple. So my image coordinates I can write down right here. So for P prime, I'm going to take negative 1 times 3, that's negative 3. So I'm just going to multiply each one of these by 3. Okay, so I'm just going to take all my coordinates and multiply by 3. Okay, 2 times 3 is 6. So P prime is negative 3, 6. Then I can do Q prime. Q prime is going to be 3 times 3 is 9. 3 times 1 is 3. 9, 3. And then R prime, that is just going to be 3 times 2 is 6. And negative 1 times 3 is negative 3. So those are my new points. So whatever my scale factor is, and if it was less than 1, like 1/2, you'd multiply them all by 1/2. Okay, so it's what you multiply by, and you're multiplying them all by the same thing. That's what's keeping the ratio. Now I'm just going to plot my new points. So negative 3, 6, 2, 4, 6. There is my P prime. Then Q is 9, 3. So we got 3, 6, 9, up 3, 9, 3. That is going to be Q prime. And then R prime is going to be 6, 2, 4, 6, negative 3. 1, 2, 3. And that's going to be R prime. And now I'm going to draw my shape, and it might overlap, and a lot of times it will overlap the original shape. And connect it there. And there is my answer of my dilation of my shape. Okay, so I've enlarged my shape. It is 3 times the size. Okay, and since my shape is kind of, for the most part, in quadrant 1, you can see that my image is also mostly in quadrant 1. I'm just three times away from the origin that each point is. Each point is 3 times the distance away from the origin, as the original shape was. And that's how you dilate a figure. Okay? So just whatever the scale factor is, you multiply each coordinate by that, and you draw it. Okay? If you need to pause, go ahead. Otherwise, I'm going to move on to my next slide. Okay, and my last slide here is we're going to be finding the scale factor. And finding the scale factor is fairly simple. What we're doing is looking for the number I multiplied by. So you have to be able to tell the difference between the original and the image. So there's my original because it has no prime notation. There's A. And then that square there is my image. So I want to know my scale factor, how the image compares to the regular. So in this fact, I can tell that my image is smaller, which means my scale factor is going to be less than 1. So that's something to think about. If your image is smaller, your scale factor is less than 1. If your image is bigger, your scale factor is more than 1. So that's one thing you got to watch out for, is that you might do this backwards and going, when you're doing that. But it's always from original to the image. How are you getting from there? Okay? So when I find this, all I'm going to do is pick the difference between 2 points. So I could figure out the coordinates of A, and they are 4, 2, 4, 6, 8, 10. A is 4, 10. Okay, and then B is 10, 10. So I could figure out those quadrants between those two, and I could figure out the difference. How do I go from A to B? Okay, well, they're going to have a difference of 6 spots. To go from 10 to 4, that's a difference of 6 spaces. Okay? An easier way of doing that might be just to count 1, 2, 3, 4, 5, 6. Now that's easy because it's on the line. Now it's a little bit harder if I would have chose the difference between B and C, because then I'd have to bring into effect some of the Pythagorean's theorem that we talked about the other day to find that length. So it's easier if you can stick to lines that are on the grid. Okay? Now I'm going to do the same thing for my image. Again, I can look at them and figure out my A prime, okay, and that's going to be 2, 2, 4, 5. So we got 2, 5. And then for B prime, and this is kind of nice because I help see it, that is 5, 5. So you might be able to see how I'm going from those points to those points, okay? And now I can count those spaces. 1, 2, 3, so that's 3 spaces. Okay, so how do I go from my original to my image? Well, when I'm going to do this math, I want to put my image number on top, my ending number on top. So I'm going to take my image number goes in the numerator, and my original will go in the denominator, and I can divide those. And so this has a scale factor of 1/2. Okay, now I could have just using the points. If I use points, the nice thing about using points, if I go back, just another way of looking at this, to A prime, just by using 1 point. Because remember, they're all going to do the same thing. So if you find what one's doing, they're all doing the same thing. I could just compare one of my points here. Okay, I could compare that point to that point. All right, my image divided by original, 1/2. Or I could use the other one. 5 divided by 10 equals 1/2. That'll work for every point. They all are that same number. So there's lots of ways. You can do it by counting the spaces like I did here. You can do it by finding and comparing points. And all you have to do is compare one coordinate. So they all will follow that same rule. So all you have to do, various ways of finding that rule. Okay? All right? But the two I recommend are either just counting the spaces if you can. That's easy. Or looking up the coordinates and then comparing the coordinates to see how they work. So these are the two ways that I suggest finding them. But remember, the image number always goes in the numerator, okay, and then the denominator is the original. So you don't want to get an answer of 2 here by doing 6 divided by 3, okay? And remember, think about that. Is the image smaller, less than 1? Okay, that's all I have for tonight. Have a great night, and I will see you guys tomorrow.